العالمين.
All right, this is CS50, and this is already week 7. And this is the week where we'll continue where we left off with Python, introducing you to a bit more syntax and capabilities of the language so you can solve like interesting problems. But a lot of those problems increasingly are now going to involve data in some form. After all, if you think of most any website or mobile app or process nowadays that involves solving problems, it almost always involves some amount of data, and often data at scale, lots and lots of data. And so what we're going to see first today is that yes, you can use Python to solve all the problems past that we've seen, and also some data-specific ones, but sometimes it's just going to be annoying. It's going to be a little painful. It's just going to be more work than you might like to just get to some answer. And so today we'll, too, introduce you to a new language called SQL, Structured Query Language. And this is a language that, rest assured, is actually much smaller, relatively speaking, than C and Python. It sort of does less, but it does it really well. And it's a language for querying databases, storing data in it, updating it, inserting it, deleting it, and so much more. And it's the kind of technology that's used nowadays in, indeed, web apps and mobile apps, data science, analytics, and so much more. It's really good at storing lots and lots of data. Now, this is yet another language. And believe it or not, next week, we'll introduce you to 3 more languages, HTML and CSS, which are not technically programming languages. They're all about aesthetics and markup of information, but also JavaScript, which is, in fact, a programming language. But the goals here in CS50 really are going to be to empower you to program more generally. And indeed, when you're out there in the real world, some years from now, invariably, there's going to be some new, other popular language out there. And hopefully, in this week and next week and beyond, among the goals is not just to teach you these languages specifically, but again, like how to teach yourself the future languages that we've not even heard about just yet. So with that said, let's begin with a survey of sorts. If you go to this URL on your phone or laptop, cs50.ly/favorites, a very simple Google form awaits you that's just going to ask you a couple of multiple choice questions. So go to cs50.ly/favorites, and that should lead you to a Google form that looks a little something like this, asking you first, as of now in week 7, what is your favorite language among those options here? And then further down, one more question. If you think back on problem sets 0 through 6, what was, if any, your favorite problem set problem, be it in Scratch or C or Python? So answer those 2 questions. And in a moment, I'll flip over to my screen here where you'll see, and anyone who's used Google Forms knows, the spreadsheet that's collecting now this data. Microsoft Office 365 can do the same if you use one of those forms. And what you see here now is a spreadsheet in Google Sheets enumerating all of the audience's questions. Language is in column B, problem is in column C, and each row represents one student who has responded. A few of you were super eager for class today at 8:33 a.m. Eastern Time, 10:32, 11:10. OK, so now we're getting into the actual class time here. And if I scroll down, we'll probably see a few dozen, couple hundred answers by now. And yeah, so we're getting a whole lot of answers here. And I'm seeing some patterns emerge, but it's not necessarily obvious to the human eyes what those patterns are. Now, of course, you can use Google spreadsheets. You can like highlight the data, and you can create charts magically out of it. But you can only do what Google lets you do with the data. And same thing for Microsoft Excel or Apple Numbers. But wouldn't it be nice to just be able to manipulate the raw data, relatively simple though it is, to just answer questions about the data? Maybe long-term create your own charts, customize it just the way you want, rather than beholden to like software that's off the shelf like this. Well, how could we go about doing this? Well, let me propose that we treat this data set now as what we're going to call, for now, a flat file database. We'll see today that there's fancier databases, but the simplest database in the world is really just like a .csv file. And we saw that a couple of weeks ago in C. We wrote a bit of C code that used fprintf to write data to a file using commas as the separator. We didn't really do much more with CSVs at the time, though, because it's really annoying, painful, time-consuming, not fun to use C for something like that because of malloc and memory and all that stuff. But with Python, it's going to be much easier. And so anytime you have access to some data set where you can just like download it to your own Mac or PC or your cloud environment, it's sort of a candidate for now writing code to do something with the data. Maybe analyze it right away. If it's been human inputted manually, maybe you have to clean it up by doing a lot of find and replace, but not with your keyboard, but rather with code. And so let me go ahead and do this. Let me go back to my Google Sheet here that has all of the data that's come in now. And let me go ahead and download this via the File menu here. And let's see, download. And you can see a whole bunch of options. If most formats might be familiar, but today we'll focus just on this one, comma, separated values, or CSV. That's going to go ahead and download it on my Mac here into my own downloads folder. And now I'm going to go ahead and do this. Let me go ahead and pull up VS Code in the cloud here. And if you've never done this before, there's a couple of ways to do it. But the simplest way to upload a file to your code space, so to speak, is just to sort of drag and drop. That's going to magically upload it to the server there. And we'll see that, one, it has a very long file name, which I'm actually going to clean this up because that's going to be very tedious to type in my code. So I could either right-click, of course, up here, but I'm going to use my Linux command. So let's move this file called CS50 2022 something or other, and let's just name it more simply favorites.csv. So all lowercase, no spaces, sort of good basics. Can we lower the mic a little bit too? And let me go ahead now and open up this file with code favorites.csv. I'll close my file explorer, and we'll see exactly the same data as before, but not quite as pretty as Google Sheets makes it be. Rather, we see here that I still have 3 columns, timestamp, language, problem, and then all of the values down below, including the timestamps and the answers therefore, but it doesn't have proper columns. It just has commas separating them. Now, we could very easily write Python code, just like we wrote C code, to manipulate files like this, either to write or read. But instead, let's do something that's a little more pleasant, which is indeed in the form of Python. So Python actually comes with native support for CSVs. It has indeed a package called CSV that just lets you read and write and do a whole bunch of useful stuff when it comes to CSV files. So let's go ahead and do something with this file. Let me go back here to VS Code. I'm going to close favorites.csv for now, but just remember in your mind that timestamp was the first column, language was the second column, and problem was the third. And notice because we're using commas, they don't, again, line up perfectly, but that's not a problem. There are 2 commas in every line, presumably. And I'm going to go ahead and now create a file called, how about favorites.py, so that I can start writing some code to manipulate this data. And let's do something simple. Let's just write a simple program in Python that opens this file, reads it, and prints something out, just as like a safety check that I know what I'm doing, even though it's not going to be useful. So in Python, if you want CSV support, you import CSV. And that gives you access to all the magical capabilities thereof. Let me now go ahead and use this technique to open a file in Python, which is similar in C. But with Python, I'm going to do this. The keyword with. I'm going to open a file called favorites.csv, which was the shorter name I gave it. This is optional, but just for explicitness, I'm going to open it in read mode explicitly, just like fopen took a second argument as well. And I'm going to name this file, once opened, quite simply file, though I could call it anything I want. And now it's just an open file. So far as Python knows at this moment, it's just text, or better yet, it's just zeros and ones. If you want this Python package called CSV to actually do something useful with it, you have to load this file now into the library. And the simplest way to do this is to give myself like a variable called reader, because I want to read this file, though this too I could call anything else. I'm going to then set that equal to the return value of a function called csv.reader. And I pass to that, per the documentation, the open file. So step 1, I open the file, and this just gives me access to the bytes therein. Step 2 now, with csv.reader, tells the Python package called CSV to do something useful with it and start analyzing the commas and allow me to parse it further. So let's go ahead and do this. Let me go ahead now, and within this loop, let's say this. Within this open file, let's do this. For every row, if you will, or line in the file, aka reader, let's go ahead and print out just how about row bracket 1. Now, what's going on here? Well, it turns out if you read the documentation for the CSV reader function, what it hands you back is essentially this special object, so to speak, that allows you to treat it as though it's just a really big list of lines from the file, aka reader. So by saying for row in reader, this is a way more succinct way of saying, give me the first line in the file, plus plus. Give me the second line in the file, plus plus, and so forth. That we would have done much more mechanically in C. This is just much more Pythonic and English friendly, if you will. So in every iteration of this loop, row is going to contain all of the data from the current row. But better yet, what the reader function does for me is it hands me each row not just as a big string or str of text in Python. It gives me what, apparently, based on the syntax on line 6? Any instinct? Yeah. It's giving me back indeed a list. And I presume the visual clue for you was the fact that we're using square brackets here. And indeed, row bracket 1 is going to be not the first, but the second element in that list. And so just take a guess. When I run this code in a moment, what's going to get printed? The timestamp, the language, or the problem? The language, because it's the second column that is in the file delimited by those commas. So let me go ahead and do this. Let me clear my terminal down here. Let me run Python of favorites.py and enter. And there's everything. It was super fast, but there's a really long list here. And in fact, if I increase the size of my terminal and start scrolling up, you'll just see all of the raw data. Now, this isn't that useful yet. I could have just glanced at the CSV, but clearly now I have the ability to open the file, parse it, so to speak, that is, break it up into its constituent parts, and do something with specific parts therein. All right, so if I want to do this a little more pleasantly, though, let me at least make this semantically a little cleaner. And you know what? Just for clarity, let me just give myself a variable. It's not strictly necessary, but I know that this is the favorite, for instance, language. So let's just call it favorite, set it equal to row bracket 1. And now just to be more explicit in my code, even though, again, we don't need the variable per se, this code's, of course, going to do the same thing. It's just using an additional variable called favorite. If I go down here, scroll up, run the program again, I get back the exact same data. But this is a stepping stone to something that's even more powerful about Python support for CSV files, is that you don't have to just treat the return value as a list with 0 and 1 and 2. So just thinking intuitively here, why is this maybe not the best design to hand you, the programmer, back the data in a list that's numerically indexed with 0, 1, 2? It clearly works, but critique this. What could go wrong? What's a little poorly designed? Yeah?
You have to always remember like what the things are, like what the order is.
Yeah.
Language, and then I forgot the last.
Exactly. So it's up to you to repeat. It's up to you to remember like what column the data is actually in. And God forbid you're collaborating with someone else on the spreadsheet. If you've used Google Spreadsheets, you can move columns around, maybe just because you want to visually reorganize things. And if you do this, and then someone else downloads that same data, all of their code is going to break. So that's just really bad design. It's fragile just because you're sort of on the honor system that 1 means the data that you want. So wouldn't it be nice if we could be a little more explicit? Well, recall that the very first line in this file is actually, and I'll scroll back up to see if, actually, let's do this. The very first line in this file is actually this. And I paused the output this time so that we can see more optionally. I just reran favorites.py. And notice one of these things is not like the other. Every output was either Scratch or C or Python, except for this first one. Why am I seeing the word language here? Where did language come from? You didn't have the ability to manually input. Oh, no? Where did it come from? Yeah. Yeah, the header, the very first row in the file, which by human convention generally just defines what the columns represent so that there's some human useful information there. Now, that's not really intended to be part of my output at the moment. So there is a way to skip this. If you want to skip the first row, you can actually do something like this. You can say next row, and that will just ignore that row so that I'm starting really with every row thereafter. But there's a better way to handle this than that. That will get rid of the row in the output. But let me go ahead and use a different feature of the CSV package that's just going to make this a little cleaner altogether. So let me clear my terminal window here. Let me undo this next thing that I just added. And instead of using a reader, let me go ahead and use a dictionary reader, abbreviated dict reader, that's going to now return me the equivalent of all of the rows, one at a time. So I can still call it reader just as before. But as the name implies, what this reader is going to return is not a list after list after list, but a dictionary, a dictionary, a dictionary. And remember, a dictionary is just a collection of key value pairs. So what does that mean? What are the keys? What are the values? Well, now that I'm using a dictionary reader, I can actually do this. Instead of sort of on the honor system remembering that I want column 1, I can treat row now, not as a list, but as a dictionary. And that means I can go in here and say, quote unquote, language. And we saw that back in week 6. Python allows you to index into dictionaries using square bracket notation in strings or strs on the inside, just like lists allow for numbers. But this now, I think, is going to be a little more robust. If I run this again, Python of favorites.py, All of that worked out fine. And let me pause the output too by using this program called more. Now I don't even see the header. So now whoever works it with Python wrote the code for this package to just analyze that first line of code, use the header, as you just called it, as the keys. And then every time you iterate through this loop, it updates the values, but the keys stay the same. Any questions then on this technique? Suffice it to say, this would be painful in C. Yes? Exactly. So the keys are always going to be, quote unquote, timestamp, language, and problem. But on each iteration of this loop here, the row is going to contain a different row of values, different row of values, different row of values. So you're going to get back one dictionary for every student who submitted the Google form, if you will, while iterating through it there. All right, so once we have this ability here, why don't we go ahead and transition to, how about not just using that dictionary reader, which makes the code a little more robust, because now if you move the columns around, no big deal. It doesn't matter if the numeric indices change. You can still use those keywords instead. But let's actually analyze the data now. I'm just spitting it out, which is not solving any problems for anyone. So let's go ahead and count the popularity of Scratch, C, and Python and see what everyone's been thinking here. All right, so how might I do this? Well, let me go ahead and do this up here. Before I start iterating, let me give myself, let's say, 3 variables. And to keep things simple, I'll say one variable called Scratch, set it equal to 0 for 0 students so far. C is going to equal 0, and Python is going to equal 0. There's a slightly prettier way of doing this, just because this is like 3 lines of code to do something very simple. You could alternatively, in Python, but not C, do Scratch, comma, C, comma, Python equals 0, comma, 0. So kind of slightly more elegant, just to fit it all into one line. But now let's just do something more interesting. On line 7, I'm still going to figure out what the current favorite language is. And now I'm just going to do some conditional checks. How about if that favorite equals, quote unquote, Scratch? Let's go ahead and increment Scratch by 1. We can't do plus plus in Python, but we can do plus equals 1. How about if favorite equals C? Then let's do C plus equals 1. We could do else. This is actually a good design question. Should I do else? Should I do if? Any instincts here? Yeah. Yeah, really good instincts. Just in case someone goes and adds another language to the form next week, because we're obviously going to introduce another language today, you don't want your code to now artificially inflate the scores for Python just because you're conflating multiple languages together. So the more defensive, sort of better way to write this code, I agree, would be if favorite equals Python, then let's go ahead and increment Python plus equals 1. And if there's a new language next week, we're obviously going to have to update the code, but at least we're not miscounting. We're just missing the new language. So I think that's slightly more robust. All right, now at the very bottom of this program and outside of the loop, when I'm all done counting, let me go ahead and print out using some F strings. How about the total number of people whose favorite is Scratch? So this is just week 6 F string syntax. Let me go ahead and print out another F string for C. And I'm, of course, putting the variables in curly braces, all lowercase, but the English words I'm doing capitalization for. Let's do a final one with F, Python, colon, and then in curly braces, Python, close quote. And I think I'm done. So let me just hide my terminal for a second. Here's the total program. Same stuff as before. Open favorites.csv. Open it further with the dictionary reader to do that processing for us. Initialize 3 variables to 0, just so we have something to count with. And then iterate over the file, row by row. And this is just some sort of week 1 style conditional logic, albeit in Python, counting things. All right, so how can we now execute this? Let me go back to my terminal, Python of favorites.py. And here we go. As of today, everyone who's reporting in live via the Google form, their favorite languages are... Interesting. That's pretty interesting, too, after just 1 week of Python, no less. But Scratch is a healthy contender there, a lot of C, so a pretty good mix here. So is this going to be the best way to write this program? long term? Well, as you noted, if there's a new language next week, this week, we're going to have to constantly update this. And here's where you should let your mind wander to like the future. Like if we have a 4th language, 5th language, 6th, 7th, 8th, which aspect here might kind of have some code smell to it? Like this probably isn't the best design to set us up for the future. What might be better than this? Yeah? Yeah, we have to keep adding a language to line 5. And OK, not a big deal. We could add like SQL today and maybe JavaScript next week. But you know, anytime a line of code, a line of logic is just going to kind of grow out of control, and we've had this chat a couple of times with different syntax, there's probably a better way than that. So let's do that. Instead of using these individual variables, we could maybe use a list. But a list would be a little confusing because like what does bracket 0 mean? What does bracket 1, bracket 2? But a dictionary, recall, is like this Swiss Army knife of data structures whereby you can associate anything with anything else, keys with values. So I dare say a cleaner way to solve this problem that sets us up for less work or confusion later would be to create like a new variable called counts, if that's what we're doing, counting things up, and just set it equal to an empty dictionary. And you can literally say dict with the open parenthesis, close parenthesis, and nothing. Or the more Pythonic, just use open and close curly braces with nothing inside. That gives me an empty dictionary, just like square brackets gives me a list. Now, my logic down here has to change a little bit. But what's nice is I don't need one conditional for every language. Because again, if we have a 4th, a 5th, a 6th, that chunk of code is also going to grow a bit out of control too. So I can get rid of this here. And what I think I'm going to do is say this. Whatever the current favorite is from the current row in the file, why don't we go into our counts variable at that key. And again, favorite is a variable. It's not quote unquote favorite. It's going to be Scratch or C or Python. And then why don't we go ahead and just increment whatever the value of that count is at that key. Now, this is technically buggy. We're really close, but there is a bug. Does anyone want to conjecture what the bug is? Yeah?
Well, this is more a question, but like, will that automatically add a new key value pair for each favorite, for each like language?
A good question that answers my question nonetheless. So no, like the magic you described will not happen. And to repeat the hypothesis, will this automatically create a key for every language that we try plugging into those square brackets? Short answer, no. Odds are this is going to create a key error, one of those traceback error messages that you've probably seen by now, either in class or in problem sets, whereby if Scratch hasn't appeared in the dictionary before, or C or Python, like then the dictionary has no clue what you're talking about. So I think we actually still need some conditional logic, but not that's going to grow longer and longer with each language. What I think we probably want to do is this. If the current favorite is in the counts dictionary, and this is the Pythonic way of just saying, is this key in this dictionary, then go ahead and safely do counts favorite plus equals 1. Else, to your conjecture now, else what do I want to do? Counts favorite equals, yeah, 1. So initialize a brand new key to a brand new value of 1, because I'm obviously just seeing this language. Otherwise, increment again and again. And now down here, I just need to tweak my syntax a little bit. I don't need to print out all of these things one at a time manually. I can actually get away, I think, with another loop at the very bottom here. So how about I do this? For each favorite in those counts, and this is, again, the Pythonic way to iterate over all of the keys in a dictionary, go ahead and print out, using an F string, whatever the current favorite is, Scratch or C or Python, and then a colon, and then figure out what its count is. And you can do that by going into the counts dictionary, looking at the favorite key, and get back its value. So I close my curly braces, I close my quotes, and even though this looks ugly at the moment, now this is much more dynamic. Because if we go and add SQL to the CSV file tomorrow, or we add JavaScript next week, this will just work. It will keep working now automatically. All I change is the Google form, not my actual code. All right, let's try Python of favorites.py. Cross my fingers as always, and there now is the data as of now. Questions on this code here? Yeah? Really good question. What if you wanted to print it in a particular order? Well, I could give you a couple of solutions. Like if you want to print it out in It's already coincidentally in alphabetical order, so you got that for free, although that's just by chance here. But there is a way to do this. And let me propose that we go down here to my loop, and I explicitly use a function you might not have seen in Python yet, but it's literally called sorted, which is going to take either a list or, in this case, a dictionary, and by default, sort it by key alphabetically. Now, if my intuition's correct, this is not going to change the output because it's already alphabetical. But if you read the documentation for the sorted function, it takes multiple parameters potentially, some of which are named parameters. And so you can actually do this. If you want to sort the counts, but you want to reverse the order for whatever reason here so that it's reverse alphabetical order, now let me go ahead and rerun this. And I'll keep the previous output on the screen. Enter. And now it's backwards alphabetically, if you will. Other questions on this here? No? How about then we transition to sorting by value. And this is going to escalate a little quickly, briefly, but then we'll tone it down again. Notice that right now this is indeed sorting by key. What if, especially if I have lots of data, it'd be nice to make like a top 10 list, or in this case, a top 3 list, and actually see in order of the counts, the values, what these popular ones are. So it's not C, Python, Scratch. It should ideally be Python, then C, then Scratch because of the values and the magnitude thereof. So how can I do this? Well, it turns out there's another parameter that you can pass to the sorted function that is typically implemented as a function itself. And so I'm going to go ahead and do this. I'm going to temporarily define a function called getValue, just to make my life easier. And this getValue function is going to take, I'll say, a language parameter. And then all I'm going to do is return whatever the count is of that language. So out of context, this is just a super simple function that you handed a language like Scratch or C or Python. It's just going to tell you what the count is thereof in that dictionary called counts. But what I can do now down here in my newly introduced call to sorted is I can tell it what to use as its key. Instead of using literally the key, Scratch, C, Python, I can sort of override that behavior and say, you know what? To figure out what to sort by, go ahead and call this function called getValue. Notice that I have not put parentheses after getValue because I don't want to call getValue right then and there. I want to pass the getValue function as itself an argument to the sorted function so that the sorted function, written years ago by the people at Python, can call my version of getValue again and again and again when they try to sort this actual data. So now, if I add that and I leave reverse equals true, let's see what happens. Python of favorites.py, enter. And now I get my top 10, or in this case, top 3 list. And if I had more sophisticated data with like more columns altogether that I actually care about, I could even sort this more powerfully as well. But let me clean this up a little bit just so you've seen it, even though we won't use these that often in CS50 until the end of the class will they come up again. Technically, this is a little bit, this isn't necessarily the best design to spend all this time implementing a function and then only use it in one place. In general, we've argued that you don't necessarily need a variable if you're only going to use it in one place. You don't really need a function if you're only going to use it in one place. And here, we kind of have a good candidate for that. And so it turns out in Python, if you don't want to bother creating a function just to use it once, you can create what's called an anonymous function, aka a lambda function, like the lambda symbol, familiar. And a lambda function, the syntax is a little strange looking, but you say this. You literally say lambda. You literally then say the name of the argument that you want this anonymous function with no name to take. Then you have a colon. And then, quite simply, you write what you want the return value of this function to be. You don't even say return literally. These lambda functions are meant to be used super tersely so that you can, in one line, express something like this. And I admit this looks more cryptic, I think, than the previous version. But as you get more comfortable with Python or other languages that support this feature, it allows you to not bother with lines of code like that and just tighten up your code a little bit. So this line here, lambda, language, colon, counts language, is the one-line version of this. And you don't even need to bother picking a name for it. Lambda tells Python, I didn't waste any time thinking of a name for this function. So questions then on this technique of using Python to analyze data like this? Any questions? We're almost done with Python. Questions? No? OK, so why don't we make things a little more interesting, because we had a much juicier data set with the problems that we've assigned over the past several weeks. Why don't we go ahead and quite simply, I think we wrote pretty darn good code here, so I think we can pretty much just change a bit of it to say, let's see, if I don't want language, I want problem. And if I want to sort by not language but problem, I think that's it. I think if I didn't overlook something here, just by changing what column I'm reading the data from, and then just to be consistent, renaming my variables just so I know what I'm looking at, what will this program now do after those minor changes? What will I see when I run this? What would be the first thing I see when I run this? Tough crowd today. Yes? Yeah, the problem, the top problem. So the most popular problem, which I'm a little worried it might be hello or just scratch, but let's go ahead and see. So let me go ahead and open my terminal window. I'll even maximize my terminal window so we can see a lot. Let me go ahead and run Python of favorites.py. I'm going to go ahead now and cross my fingers that I didn't mess up and hit enter. And OK, great. We peaked early. So Scratch was the most popular program according to the data at the time I downloaded it. I'm sure other votes have come in since. Filter in week 4 was tied then with Tiedemann as well. Mario is a close third there, and so forth. So this is helpful for us on staff. That's not so much love down here at the bottom of the list. So it was a bunch of code to write, but now that we've written it in this very versatile, dynamic way, it's pretty good for just like crunching data and doing some analytics. But it's still a decent number of lines to have had to write manually. And this is where sometimes it isn't necessarily the right tool for the job, but rather the job that but rather a candidate for using some other language altogether, especially when it's not just a one-time program that you run and you want to see the answer. What if you want to take input from the user and answer questions dynamically, like a mobile app would, like a website would, like Microsoft Excel or Apple Numbers or Google Sheets would for you? Well, let's make one final change for now to this version of the program and actually take in some user input. So besides just loading all of the data into memory, let's go ahead and down below here, not just print out the top 10 list, if you will, but prompt the user for their favorite. So I'm going to use Python's input function, and I'm just going to prompt them with favorite, quote unquote, like tell me what your favorite problem, what problem you're interested in. And now let me go ahead and say if that favorite is in the counts variable, so you didn't type in something random that we didn't actually assign as a problem, then let me go ahead and print with a format string whatever that favorite is of yours and show you the actual popularity thereof by indexing into counts using that favorite as the key and printing this. So now it's a dynamic program. It doesn't dump all of the data and all of the summations. Rather, it's going to allow me to see what my choice of favorite is. And I'm going to go ahead and say, let's see, I'm a fan of Mario here. So enter. And indeed, we see the same value we saw a moment ago, but just for Mario. But the point now is that, 1, all of this is possible. 2, it's way easier and more pleasant than this would have been in C. This is still only 15 lines of code. And in C, again, there's the memory management. There's the iterating over the strings, trying to find the commas. There's just a lot more work. But honestly, even when you just want to answer a question like this in Excel, in Apple Numbers, Google Sheets, generally you can just highlight things. You can click a button and boom, you get your answer for summation or max or min or any of those sort of basics. Wouldn't it be nice if we weren't taking a step backwards as programmers and being sort of more powerful, and yet we now have to do more of the work? So maybe sometimes Python's not, or any language is not, the best tool for the job. And that's going to now allow us to introduce more generally something called a relational database, graduating from mere flat file databases like text files or binary files in which all of your data is stored to something more proper. But first, questions.
With in and for favorites in counts, is that case sensitive? Like if someone were to type like lowercase Mario, would it still return that it was in counts?
Really good question. To reiterate, if I were to, is this case sensitive? So if I were to type in Mario in all lowercase and hit enter, I actually get no such response. Now, that might be acceptable because the problem technically what is a capital M, but that's a little ridiculous to be that pedantic about the input. So how could we solve this? Any tips for how we could make this a little more robust? Yeah? OK, yeah. Yeah, so we could use a few different functions, one of which is called title, which will change it to title case, where it capitalizes, like in most English sentences, the first letter of that sentence. We could use capitalize. We could use upper. We could use lower. But indeed, we could just decide how we want to standardize the capitalization, either uppercase, lowercase, or some combination thereof, and just make sure that you change the counts themselves, make sure that you do the same to favorite, and make sure that maybe you keep a backup of the data if you want to show the original version that came from the CSV without presuming to just capitalize everything for the user. But indeed, that would be the most common scenario. You just make things case insensitive when doing those matches. Other questions now on Python before we leave it behind for the coming week